We were discussing regarding analysis of stresses and strains in composite section and temperature stresses. So first, we studied what is a composite section. So composite section means it's an object or a part or a component which is made up of more than two materials. So this first diagram, if you consider there are two materials, one is aluminum and second one is steel, and whatever load acting here will be shared between aluminum and steel. Therefore this combination can be considered as a composite structure. Or else this concrete reinforcement, if you consider, there will be steel rods surrounding to which concrete will be there. So even this one can be considered as a composite structure. When load is acting, this load value will be shared among steel rods and also concrete structure. So we have to remember two equations. One, total load acting is equal to load on first material or load carried by first material plus load carried by second material. If there is one more material apart from this, if there is one more steel or aluminum component, then total load will be shared between all the three materials. So this is the first equation to remember. So this one, and apart from this, one more thing you have to remember in case of composite section is, whenever some load is acting here, these sections will undergo deformation. This aluminum and steel bar will undergo deformation, and deformation in both material will be same. So delta 1 is equal to delta 2. So these two things you have to remember. And delta is given by FL by AE. We have studied this equation in first chapter. Delta is equal to FL by AE. So for steel it is Fs, length of steel, area of steel, and Young's modulus of steel is equal to, for aluminum, F aluminum, this is aluminum, then length of aluminum divided by area of aluminum and Young's modulus of aluminum. So we have to use these two equations while solving any problems. And we have seen one problem in the previous class. And in today's class, we'll solve two more problems on composite bars. And next class also we'll solve last one more problem on composite bar. So that completes composite bar topic. So in composite bar, you have to remember only these two steps to solve any problem. Total load is equal to P1 plus P2 plus, if there is one more material, then P3, and delta 1 is equal to delta 2 is equal to, if there is one more material, delta 3. So these two things you have to remember for composite section. Usually in external exam you will be having one problem from composite section and one problem from temperature stresses. So we'll move to next problem now. Hidden question. This is actually this problem is not there in textbook. I have modified the question, and this is somewhat related to practical example. You have to design a bench or else a platform you have to design. So this is the platform. You can note down question. Or else like this one bench you have to design. Bench. This bench is having, assume 3 legs. It's having only 3 legs. One here. So bench is having 3 supports. These supports are made up of 2 bronze rods. So this is bronze, this is also bronze, and last one is steel rod. So 3 supports are made up of different materials, 2 bronze support and 1 steel support. The maximum permissible stresses in bronze and steel, it's given. It should not exceed 50 Newton per mm square and 100 Newton per mm square. You have to find out what is the maximum load that can be placed on this table. You have to find out what is the maximum load that can be placed on this table. And last, one more sentence is given. Young's modulus of steel is twice that of Young's modulus of bronze. That means Young's modulus of steel, ES, is equal to 2 times Young's modulus of bronze. Take down diagram also. Actually, few dimensions are missing here. We'll write the dimensions as well. Take down question. This is 300 mm, and below this one is 200 mm. These two dimensions are given. And apart from this, area of bronze and steel is given. Area of bronze is 40 into 40. Somewhere here I will write. Area of bronze is equal to 20 into 20. It's a square section. So 20 into 20 mm, 20 mm into 20 mm. And area of steel is 50 into 50. 50 mm into 50 mm. This is given in the question itself. This is given in the question. So what exactly you have to find out here? You have to find out what is the maximum value of P that can be placed, or that can be placed on this platform. Note down given values. Given value. So in first sentence, you have to design a platform, or you have to design a bench that is having 3 supports. Supports are made up of 2 bronze and 1 steel. Maximum permissible stresses in bronze and steel. Okay. So sigma values are given. Sigma in bronze, this is 50 Newton per mm square. And sigma in steel is given. Sigma in steel is 100 Newton per mm square. 100 Newton per mm square. You have to find out the mass or load value. And here in the end, one more sentence is given. Young's modulus of steel is twice that of Young's modulus of bronze. Young's modulus of steel is equal to 2 times Young's modulus of bronze. Actually, from this definition itself, Young's modulus of steel is 2 times Young's modulus of bronze. It's understood that the steel is capable of withstanding 2 times more stress compared to stress that can be withstand by bronze. So same thing is given here. Steel can withstand a stress of 100 Newton per mm square because its Young's modulus is more, whereas bronze can withstand only 50 Newton per mm square because its Young's modulus is half that of Young's modulus of steel. So if Young's modulus of any material is more, it means that it can withstand more amount of load or more amount of stress. Okay, so we'll solve this problem. I said in every composite problems, there will be 2 steps. First step, total load will be shared between each supports. So PB plus PS. There is one more bronze support. So PB. There are 3 supports here. So PB plus PS plus PB. And this one can be simplified like PB plus PB 2 times PB plus PS plus PS. Now substitute, the equation sigma is equal to force by area. And in previous class, I told you instead of P, you can write F also, because in first chapter, force, we have taken it as F. So you can replace P by F, not a problem. This notation you can change. Therefore, F is equal to, from this equation, you will get F is equal to sigma into area. Substitute F is equal to sigma into area in this equation. So this equation will become P is equal to 2 times, instead of PB, we'll write sigma B into area of B, 2 times sigma bronze plus area of bronze plus this PS I can replace by sigma S into area of steel. Sigma S into area of steel. Hope this step is clear. So total load is shared between 2 bronze and 1 steel. And this force or P value will replace by sigma into area. So this is using equation for sigma is equal to force by area. Substitute all known values. P is unknown, you have to find out. 2 times, what is sigma B? It is 50. It's given in the question. Sigma B is 50. What is area of bronze? Area of bronze is given here, 20 into 20. 20 into 20 plus sigma S value is given in the question, that is 100. 100 into area of steel is 50 into 50. 100 into 50 into 50. You will get total load that can be placed on this table or platform. You will get P value as 2 how much you're getting? 50 into 2.
2,90,000.
Okay, so Right, whatever answer you are getting, Newton, 2 lakh something you are getting. So after this, there comes one more equation. After this, there comes one more equation. We'll write it here. Delta steel is equal to delta bronze. Actually, there is a small mistake here. We'll tell you later. So after this step, I will tell you. So delta steel is given by force acting on steel, Fs, into length of steel divided by area of steel into Young's modulus of steel is equal to, then bronze related terms, Fb length of bronze divided by area of bronze into Young's modulus of bronze. You can substitute all known values. While substituting all known values here, this F by A, I can write it as, you can see here, F divided by A, I can write it as sigma. So this equation will become sigma S. I'm replacing F by A using sigma. So sigma S into Ls divided by Es is equal to sigma B, where sigma B is Fb by AB into Lb divided by EB. Now I tell you what is the mistake in first step. So if you consider this equation, here all the values are known, all the terms are known. Sigma S is given in the question, length of steel is given, Young's modulus of steel is given. So all the terms are given. Then what exactly to find out? So here the mistake is, whatever sigma value given in question, there is a word called permissible. Its meaning is that the maximum permissible stresses in bronze and steel should not exceed 50 Newton per mm square and 100 Newton per mm square. That means actual stress developed is not 50 and 100. Actual developed will be less than 50 and 100. But according to given condition, maximum stress should not exceed 50 and 100. So here what I will do is, in this equation, sigma S is, here sigma S and sigma B are the actual stresses developed in steel and bronze, which is unknown, you have to find out. Whereas 50 and 100 are the maximum permissible stress. So we'll write it as it is, sigma S into length of steel. Length of steel is 300 plus 200, it is 500, divided by Young's modulus of steel, we'll write 2 times EB, 2 times Young's modulus of bronze is equal to sigma B is unknown here, into length of bronze is 300 divided by EB. Cancel common terms. EB is common. So when you simplify, you will get sigma S is equal to 1.2 times sigma B. Let it be equation number 1. You will get sigma S is equal to 1.2 times sigma B, and this is equation number 1. Take down.
See the equation answer.
Sigma S is equal to 1.2 times sigma B. This is equation number 1. After this, then calculate what is sigma S. When you calculate sigma S, we'll write here sigma S is equal to 1.2 times 1.2 times maximum value of sigma B is given here. This is not the actual value of sigma B developed. This is the maximum permissible value of sigma B. So maximum permissible value of sigma B is 50. So calculate what is sigma S. Sigma S is equal to 1.2 times into 50. You will get 60. Sigma S has 60. And this answer should be, you're getting 60. For safer side, or I'm getting this answer as 60, and this answer should be less than maximum permissible stress. Maximum permissible stress is 100, and if actual sigma S is less than this 100, then the design is safe. So I'm getting actual stress as 60 Newton per mm square, which is less than maximum permissible stress. Therefore, design is safe. So after this, one last step. In this step, we'll substitute sigma B as it is, area, everything will be same. Your area of sigma S instead of 100, will substitute sigma S as 60, because this is the actual stress developed in steel. So instead of 100, substitute sigma S as 60 and calculate. You will get final answer, total load, as I think you are getting 310 kilonewton.
Sir, should we not calculate sigma B?
You can calculate sigma B also. 1 second, we'll tell you. So after this, we'll tell you. I don't know the actual answer here. Maybe around 310 kilonewton something you're getting. Not 310 kilonewton, less than 310 kilonewton. Actual answer I'm not having. Yeah, one more thing. 2 into 50. Yeah, correct.
Sir, again we should only change the value of sigma S. We should not change the value of sigma B.
Yeah, instead of 100, we'll take actual sigma developed in steel. Actual sigma developed is 60, so we'll substitute value of 60. And here instead of 50, we'll calculate actual sigma B also. So after this, I will tell you. So you can calculate actual sigma B also. sigma B is given by, so from equation number 1, sigma B is equal to sigma S divided by 1.2 sigma S divided by 1.2. Sigma S is 60 divided by 1.2 divided by 1.2, you will get
50.
60 divided by
50.
1.2, exact 50 you will get.
Yes.
So you are getting same answer here, 50. So you need not calculate it once again. So if sigma S is 60, automatically sigma B will be 50. So that value itself you can substitute. So we'll tell you once again how the solution is. First, in every problem you have to consider two equations. First equation, total load is equal to load carried by individual sections. Here there are two bronze sections and one steel section. So 2 times PB plus 1 time PS. Instead of P or instead of force, you can write it as force is equal to sigma into area. So I will replace force by sigma B into area B, also sigma S into area of steel. Here whatever stress value is given in the question, it is maximum permissible stress. This is not the actual stress developed. So you should not substitute 50 and 100 directly here, because 50 and 100 is the maximum stress, maximum permissible stress. So keep it as it is. Then go for second equation, delta S is equal to delta B. Deformation in steel is equal to deformation in bronze. Substitute for deformation equation, it is FL by AE for steel is equal to FL by AE for bronze. I can replace force by area using sigma S and force by area using sigma B. Substitute all known values, you will get one equation, sigma S is equal to 1.2 times sigma B. Using this equation, find out what is actual sigma S. Actual sigma S will be 60. You can also calculate what is sigma B using this 60. Obviously, you have to get same answer. You will get 50 only. And substitute this 50 and 60 in previous equation, force equation or load equation. You will get a maximum load that can be placed on this platform. Problem very similar to previous problem. So we'll solve last one problem, then we'll wind up. Okay, we'll move to next problem then. Last one. Taken question. A weight of 300 kilonewton is supported by short concrete column of 250 square section. Column is reinforced with 4 steel bars and 4 steel bars of cross section area of 5500 square. Find the stresses in steel and concrete if Young's modulus of steel is equal to 15 times Young's modulus of concrete. Stress in concrete should not exceed 4.5 meganewton per meter square. Find what area of steel is required to support a load of 500 kilonewton. Actually, this subject, mechanics of material subject, same syllabus, even civil people will be studying this subject. But the subject name is different. I think it is strength of materials for civil students. But syllabus, if you consider, it's maybe 100%, if not at least 90%, it is similar. Take down question. This question is somewhat like there is a reinforcement. Reinforcement means a structure like this. One concrete pillar you have to design. Concrete pillar. In this pillar, there will be steel rods inside this. Steel rods surrounding to that concrete will be there. How many steel rods? There are 4 steel rods. We'll show in this top view. First, second, third and fourth. 4 steel rods. Given values, W is equal to 300 kilonewton. It is supported by a concrete column of 250 square section. 250 square section means this side is 250. It's a square section of dimension 250 each. 250 each. This diagram is not given in the question. You have to draw this diagram based on statement. A square section of 250 side. A square section of 250 side. Column is reinforced with 4 steel bars. You can see 4 steel rods here of cross-sectional area 5500 square. So area of steel is equal to 5500 square. What is the meaning of this sentence? It's given that there are 4 steel bars, these 4, and the cross-sectional area of steel bar is 5500 square. So cross-sectional area of this hatched portion or steel bar, it is 5500 square. Find the stresses in steel and concrete if Young's modulus of steel is equal to 15 times Young's modulus of copper, Young's modulus of concrete. So what is the meaning of this sentence? Its meaning is that this steel rod is capable of withstanding 15 times more load compared to concrete. And somewhere in the previous class also I told you, in this pillar if you consider, there will be steel rod as well as concrete. The function of steel rod is mainly to support the load. Major amount of load will be supported by steel rod. But what happens if only steel rod is present? If only steel rod is present, what happens is, due to load, this steel rod, because its length is more, because of that it may bend. So just to avoid that, we are providing concrete surrounding to steel rod. So this concrete will hold the steel rod together, and it will say that steel rod will not bend when the force is acting. And what if I use only concrete? If I use only concrete, this concrete is having smaller Young's modulus. Smaller Young's modulus means it is capable of withstanding only small amount of load. There may be crack in pillar or crack in column because of the load. So that is the purpose of using both steel and concrete. Steel will carry the load. Concrete will hold the steel rod together. So this is given. ES is equal to 15 times EC. If the stress in concrete should not exceed 4.5 meganewton per meter square. So stress in concrete, sigma C I will write. Sigma C should not exceed 4.5 how to convert mega Newton per meter square, or mega Newton per meter square is Pascal, megapascal to Newton per mm square. So 1 megapascal is equal to 1 Newton per mm square. So this becomes 4.5 Newton per mm square. So these are the given details, and total load is given. Sorry, this is the second sub question. Sorry, from here this is the second sub question actually. Here onwards, this is the second sub question, so we'll not consider this one right now. For the time being, we'll not consider this one. So till here, this is first question, and after that, there is one more sub question. So we'll solve the first question now. You have to find out what is the stresses in steel and concrete. So as usual, I'm having only two equations. First equation, total load is equal to, we'll write F only. Total load is equal to F in steel plus F in concrete plus F in concrete. This F value, similar to previous problem, F value, you can write it like sigma steel into area of steel plus sigma concrete into area of concrete. Substitute all known values. When you substitute all known values, what is total force? It is given in the very first sentence. Total load is 300 kilonewton. So F is 300 kilonewton. This is 300 kilonewton. Sigma S and sigma C, this is unknown. You have to find out. You have to find out stresses in steel and concrete. What is area of steel and area of concrete? Area of steel is given in the question. It is 5,500. Area of steel is equal to 5,500 mm square. 5,500 mm square. But what is area of concrete? Area of concrete. Area of concrete is, it's given here, it's a square section. Therefore, area of concrete will be 250 into 250. 250 into 250 because it is a square type. But from this total area, in order to get area of concrete alone, you have to subtract area of steel. Area of steel you have to subtract. So area of steel is 5,500. So total area of concrete is equal to area of concrete minus area of steel, or total area minus area of steel That will give you total area of concrete. Last 10 more minutes. So you will get area of concrete as this answer will be 57,000, I think.
57,000.
Yeah, 57,000 mm square. This is the area of concrete. Now substitute in this equation 300 kilonewton is equal to 300, that is total load W or F. 300 kilonewton is equal to sigma S is unknown, we'll keep it as it is, into area of steel 5500 plus sigma C is unknown, you have to find out, into area of concrete is 57,000. Simplify this. You can simplify also. So this is equation number 1. You can simplify and write also. Next, second step, delta in steel is equal to delta in concrete. Delta in concrete. Delta in steel is given by F steel, length of steel, divided by FL by area of steel into Young's modulus of steel is equal to concrete related terms FC, length of concrete divided by area of concrete into Young's modulus of concrete, into Young's modulus of concrete. Again, this one will simplify. F by A, it is sigma. F by A is sigma. Sigma S into length of steel divided by Young's modulus of steel is equal to sigma concrete length of concrete divided by Young's modulus of concrete. Which are the known values in this equation? Sigma S and sigma C are unknown. You have to find out. Relationship between ES and EC is given. Yeah, it's given here. ES is equal to 15 times EC. It's given here. ES is equal to 15 times EC. What about length of steel and length of concrete? Whether length of steel and length of concrete will be same or different. So in any structure, if you consider, there will be one column, concrete column or concrete pillar will be there. Inside that pillar, throughout its length, there will be steel rod. So length of steel and length of concrete must be same. It has to be same. So since LS is equal to, since LS is equal to LC, we'll cancel out these two. Now one last step, then the equation will become sigma S divided by ES is equal to sigma C divided by EC. And substitute ES is equal to 15 times EC. Sigma S divided by 15 times EC is equal to sigma C divided by EC. When you simplify, you will get sigma S is equal to 15 times EC. This is equation number 2. This is equation number 2. Compare equation 1 and 2. 1 and 2. There are 2 equations and 2 unknowns. You can simplify this one and you can get the values of sigma s and sigma s and also sigma c. By comparing equation 1 and 2, you will get sigma c is equal to, or sigma s is equal to 32. You will get 32.25, 32.25 Newton per mm square, and sigma c you will get 2.15 Newton per mm square.
Sir. Sir.
Yeah.
In equation number 2, there are 15 into sigma c, sir, EC not.
Yeah, this one has to be sigma c, not EC. This one has to be sigma c. 15 times sigma c. So I got the value of sigma s and sigma c. Again, from this answer, it is clear that steel rod is withstanding maximum amount of stress compared to concrete. From this entire problem, a lifelong learning you need to know is, in a concrete structure, purpose of steel is to withstand maximum amount of load, and purpose of concrete is to hold the steel rod together. This is the basic or general thing that you will understand from this problem. After this, we are having one sub question. Just one more step for this. We'll solve this and we'll wind up. So complete till here.
That VPT, the bottom one not showing properly, sir.
Oh. Can you see this line?
No, sir.
I'm drawing something here. You are not able to see this line.
No, sir.
Yes,
This portion.
see.
This portion.
Yes, sir. But last line we can't see.
Last line,
Okay.
line, sir.
But if I go out of the screen, whatever things I have written in the screen, everything will vanish. If I press escape now, everything what I have written here will vanish. I will quickly tell you whatever things I have written here. So I hope you can see till here. ಇಲ್ಲಿ ತನಕ ಕಾಣ್ತದಲ್ವಾ?
Yes, sir. Yes.
So
yes, sir.
after this, next line, sigma s. So just I have simplified this one. Sigma s divided by es is equal to sigma c divided by ec. Sigma s divided by es is equal to sigma c divided by ec. Next line, we'll substitute es is equal to 15 times ec. So sigma s divided by 15 ec is equal to sigma c divided by ec. Sigma s divided by 15 times ec is equal to sigma c divided by ec. So instead of ec, es 15 times ec. 15 times ec is equal to sigma c divided by ec. After this, next line, you can cancel out ec. So next line, sigma s is equal to 15 times sigma c. So by simplifying this, you will get sigma s is equal to 15 times sigma c. Sigma s is equal to 15 times sigma c. And then the final answer, sigma s is 32.25 Newton per mm square. Sigma s 32.25 Newton per mm square, and sigma c 2.15 Newton per mm square.
Okay, thank you, sir.
So after this, moving on to second sub question, hardly 5 more minutes. So actually right now I'm getting sigma C as 2.15 Newton per mm square, but according to the second sub question, if the sigma C or stress in concrete is 4.5 Newton per mm square, then what should be area of steel in order to support a load of 500 kilonewton? So you have to find out what must be area of steel. This one you have to find out, area of steel you have to find out in order to withstand a load of 500 kilonewton, and stress in concrete is 4.5 Newton per mm square. This is the second sub question. So again you can consider this first equation. Take down question, sub question. If sigma C is 4.5 Newton per mm square, if sigma C is 4.5 Newton per mm square, and force is equal to 500 kilonewton, force is 500 kilonewton, you have to find out area of steel. What is area of steel? See, if I press escape, entire thing will vanish. So equation number 1 was 300 into 10 to the power. I'm writing equation number 1 again is equal to sigma S into 5500 plus sigma C into 5700. Sorry, 57,000. 57,000. This was equation number 1. In this equation number 1, you have to change load value. Instead of 300, you have to use 500. In second sub question, instead of 300 kilonewton, load given is 500 kilonewton. And what are the other values you have to change? Stress in concrete is 4.5 Newton per mm square. So this value is 4.5 Newton per mm square. 4.5 you have to substitute. If sigma C is 4.5, what will be sigma S? So I told you, using this expression, ES is equal to 15 times EC, which means that sigma S is steel is capable of withstanding 15 times more stress compared to concrete. Sigma S is equal to 15 times EC. So you can note down what is sigma S. Sigma S will be 15 times 4.5. You will get sigma S value 67.5 Newton per mm square. 67.5 Newton per mm square. Now substitute all values in equation number 1. Then the equation will be 500 into 10 to the power 3 is equal to sigma S is 67.5. 67.5. This is the area of steel. This is area of steel. And this is area of concrete. This is area of concrete. This was the actual diagram. $250 each. 250. 250. So here area of steel, it is unknown, you have to find out what area of steel is required. So area of steel is unknown, you have to find out area of steel plus sigma C is 4.5. Sigma C is 4.5. Then what will be area of concrete? Area of concrete is obtained by total area minus area of steel. So total area is 250 into 250. Total area is 250 square minus area of steel is unknown. Minus area of steel is unknown. Simplify this, you will get area of steel as 3472.2 mm square. This is the final answer. We'll tell you how did you get this one, this value. So if you have any doubt regarding this, so here what exactly how to substitute? You have to substitute area of concrete here, concrete alone. Area of concrete you have to substitute. And how did you get area of concrete? Area of concrete is given by area of concrete is equal to total area. In first sub question we have seen total area minus area of concrete, area of steel. Area of concrete is equal to total area minus area of steel. Total area is 250 into 250. Total area is 250 square. Total area is 250 square minus area of steel is unknown, you have to find out. So this term will become 250 square minus AS. By simplifying, you will get area of steel as 3472.2 mm square. Usually in most of the question paper, if you refer, this type of one question will be there based on concrete and steel structure. Hope you have taken that.
So should
Final
we
answer.
not take the mega over there, 4.5 mega Newton per meter square?
Actually, if you convert .5 mega Newton per meter square, you should convert this one to Newton per mm square, then it becomes 4.5 mega Pascal, and 1 megapascal is equal to 1 Newton per mm square. 1 megapascal is equal to 1 Newton per mm square. So this 4.5 mega Newton per meter square will become 4.5 Newton per mm square. It's one and same.
Yes, sir.
And again, if you know how did you get this one? Mega means 10 to the power 6. You should convert meter square to mm square. Again, it becomes meter to mm, 10 to the power 6. So 10 to the power 6 and 10 to the power 6 will cancel. So you'll be left out with 4.5 Newton per mm square. And video question papers are shared in Teams. You can go through previous question papers also. In files, I hope you know how to access this one. Go to mom channel and
Yes, sir.
in that file, video question papers, here scheme wise question papers are uploaded. You can go to any scheme Under 18 scheme, we'll be having only one question paper. You can find similar questions in external. We'll show only one question paper, then we'll wind up. It's not loading, it seems. Yeah, it's loading here. I'm not able to zoom this. Yeah, you can go through you can go through all the previous question paper, and you can find all similar questions in previous question paper. So we'll wind up today. If you have any doubts, you can contact me later. Thank you.